Okay, and we're live. Welcome back to Grockit's OGTV GMAT edition, where we go through the 12th edition of the official guide to the test. That's what it says down here in the corner of the screen. It's Grockit. My name's Jim Jacobson. That's my picture in the upper right. Welcome to the show. So last time we left off on we finished with question number 88 on page 164. We are moving on then, still page 164, on to question number 89. So 164, question number 89. And the new and improved template here has our letter answer choices already filled in. So we have 201 squared over t. Have 202 times 201 over t, 201 over t, 202 over t, and then 202 times 201 over t squared. So those are our answer choices. So if s is the product of the integers from 100 to 200 inclusive, and t is the product of the integers from 100 to 201 inclusive, what is the value of 1 over s plus 1 over t in terms of t? So we have two variables, but ultimately we can we end up being able to substitute values in here. So we're trying to find the value of 1 over s plus 1 over t. And we do find that s is the product of the integers from 100 to 200 inclusive. So it's 100 times 101 times 102 dot dot dot. It's an ellipsis all the way to times 200. It might take you the entire rest of the time on the GMAT if you were actually going to multiply that out, unless you are one of those math whizzes who can do that sort of thing in your head. The good news is you don't have to calculate it. We just need to know approximately what that is, or what it is relative to the other number. So we know that t is then the product of the integers from 100 to 201. So basically, that's s equals that. T is basically the same thing. 100 times 101 times 102, blah, 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 times 200 times 201, because remember it has that extra integer in the product. So basically, s and t are almost exactly the same number. In fact, t is exactly the same number as s times 201 in addition. So we could phrase that as t equals whatever the value of s is. Let's just pretend like we calculated that massive number with however many million zeros would be on it. S times 201 is t. Now we need the whole thing in terms of t, so we actually need to then solve for s. We would divide both sides by 201. S equals t over 201. So that's pretty cool. But we need to figure out the whole thing in terms of t, this whole thing up here, 1 over s plus 1 over t. So that's 1 over t over 201 plus 1 over t equals. Now, when you have a fraction in a fraction, you can eliminate it by multiplying something in the same thing in the numerator and the denominator. You can also say, well, anything, any number that is, anytime you're given a fraction where it's 1 over some other fraction, that's the same thing as that fraction's inverse. So 1 over t over 201 is the same thing as 201 over t. So these guys are the same here. 1 over t over 201 is the same thing as 201 over t. We are adding that to 1 over t. So since these two fractions have the same denominator, they're both over t, we can just add the numbers across the numerator, just like you could add 1/4 plus 3/4 and get 4/4. You can add 201 over t plus 1 over t and get 202. That's supposed to be a 2 over t. And that is our answer choice D, 202 over t. On to the next one. Number 90, last one on page 164. So our choices are 131, 135, 139, 147, and 188. So if Jake loses 8 pounds, he will weigh twice as much as his sister. Together they now weigh 278 pounds. What is Jake's present weight in pounds? So again, two variables. We're going to have J for Jake, and we don't get Jake's sister's name, so we'll just use S for sister. I guess if I were smart, I would have named her and given her a different variable. In general, S is not an awesome variable to use in algebra because it can end up looking like a 5 if you're not careful. If we, of course we're going to be careful, but if we weren't, it could be trouble. So J is Jake, S is his sister. We know that the two of them together are 278 pounds, so J plus S equals 278. We also know that if Jake loses 8 pounds, he will weigh twice as much as his sister. That gives us another equation. So remember, with two variables, generally you need two equations in order to solve for both variables. So Jake's weight minus 8 is going to equal twice his sister's weight. Now we're ultimately solving for J here, not S. So whenever you have these two variables, two variables and two equations, the first equation that you solve when you're substituting, you solve for the variable you're not ultimately trying to find the answer to. So we want to solve for S rather than J, so that we can substitute that value into our other equation. So if J minus 8 equals 2S, we can just say that's the same thing as S equals J minus 8 over 2, because we just divided both sides by 2. We can now substitute this value for S into our other equation of J plus S equals 278. So that means J plus J minus 8 over 2 equals 278. Now to get rid of this fraction, the J minus 8 over 2, we multiply both sides of the equation times 2, so we get 2J plus the quantity J minus 8 equals 556. So that's 3J minus 8 equals 556. So add 8 to both sides, so we get 3J equals 564. And then we just divide both sides by 3. And 564, as it turns out, divided by 3 equals 188. So Jake weighs 188, and his sister is a lightweight at about 90 pounds. So his sister's weight is not what we're solving for. We're solving for Jake. Okay, so choice E is the correct one for number 90. We're moving on to page 165. Unsurprisingly, on to question number 91, because we are doing all the questions in the book. So we have, I'm just going to start over. Let's see, 165, question 91. So 0.25, 0.50, 0.75, $1 even, and then $1.25. So a certain store sells all maps at one price and all books at another price. On Monday, the store sold 12 maps and 10 books for a total of $38. And on Tuesday, the store sold 20 maps and 15 books for a total of $60. At this store, how much less does a map sell than for a book? So we can use the two different equations that they give us, the sale values for Monday and the sale values for Tuesday. That gives us our two equations that we need for the two variables in the problem. So we have maps and books. M will equal our maps. M is a great variable to use. B will equal our books, just as S is not a great variable to use because it looks like a 5. B is not a great variable to use because it looks like a 6. Probably the only one worse is L or I because it looks like a 1. But again, we are super careful, so we can live dangerously and use it as our variable. So Monday, we'll do our Monday equation. the store sold 12 maps and 10 books for a total of $38. And both these variables, this is the map's price, and B is the book price. So 12 times whatever a map costs plus 10 times whatever a book costs equaled $38. Tuesday, we used the same price because I didn't change the prices for books or maps. 20 times that map price plus 15 times the book price equaled $60. So when you have equations like these, you can do them one of two ways. There's the substitution method, where you solve for one of the two variables. That's what we actually just did in the problem before with Jake and his 90-pound sister. In this one, we're going to use the combination method, where you get the two equations in terms where by adding or subtracting them, you can eliminate one of the variables entirely and solve the rest from there. It's worth noting that both of these methods work equally. Well, I won't say they work equally well. There's times when one equation makes a lot more sense, or one method makes a lot more sense than the other method, but if you choose the quote-unquote wrong one, as long as you do your math correctly, you will still arrive at the correct answer. So the reason we're choosing combination method here is that these variables that have the b in front of them. One of them is a 10 and the other one's the 15. So there's a relatively clear way that we can modify the Monday equation so that we end up with 15b, and then we can subtract them. So if we multiply the whole Monday equation times 1.5, we can actually get the same value for the same number of books. So 12 times 1.5 is 18, so that's 18 times the map price plus 15 times the book price. And then 38 times 1.5 equals 57, because half of 38 is 19, so $57. So now we still have two equations and two variables, but we can simply subtract the two and we will be left with only one variable. So if we subtract from 20m plus 15b equals 60, the equation 18m plus 15b equals 57, you can kind of see how this is going to work out. We are left with simply 2m, because 20 minus 18 is 2, 15b minus 15b, those 15b's totally go away, and then we're left with 60 minus 57, which equals 3. So m equals 3/2. Of course, we're not dealing with fractional dollars. We're dealing with decimal dollars, as we remember from our answer choices. So m really then is $1.50. That's 3/2 of $1 equals $1.50. Of course, we're not solving for m. We're solving for the difference between m and b. So then we have to plug the whole thing back into one of our equations. Let's use the smaller one of the two. So 12 times that map price of $1.50 plus 10 times the book price equaled $38. We already established that 12 times 1.5 is 18, so $18 worth of books plus 10 times that book price equaled 38. We subtract 18 from both sides. 10b equals 20, and then we divide by 10. b equals 2. So a book at this store costs $2. A map costs $1.50. I would love to live in a world like that where books and maps were that inexpensive, but in any case we need the value of b minus m. b minus m equals 50 cents. Choice B. Just a coincidence, but choice B is the correct answer for number 91. Number 92, still on page 165. So we have 2%, 17%, 20%, 65%, and 83%. The good news is when answer choices are spread out by this much, I mean, all of these are fairly far apart. I mean, the difference between 2% and 17% is fairly large. 17 and 20 are pretty close, but then 20, 65, and 83 are all pretty far apart, which means that it will be harder for a small computation error to lead us to the wrong answer choice. Conceptual errors where we simply just do the problem wrong are more likely to lead to the wrong answer choices on this one. Anyway, so a store reported total sales of 385 million for February of this year. If the total sales for the same month last year was 320 million, approximately what was the percent increase in sales? So a formula that you absolutely need to know for the GMAT, and I don't know, it's actually kind of useful in real life, is the percent change formula. If you need to know what the percent increase or decrease was, it's just calculated by the amount of the change in the numerator. I didn't make my thing long enough there. The amount of the change over the original amount. So we need to figure out the amount of change. In this case, going from 320 million to 385 million, let's just kind of forget the millions business because that's a lot of zeros and we don't need to deal with them. So the difference between 320 and 385 is 65. So the amount of change is 65. The original amount is the one that was further in the past, February of last year, according to the problem. So that's 65 over 320. That, as a percent, will be our number. So we can divide the numerator and the denominator by 5 to simplify the fraction. That's the same thing as 13 over 64, but then it gets ugly. We are left with then having to either estimate it or do the actual math. If you're not confident in your estimation abilities, you just do the math. So we would divide 13 by 64. Obviously, there's going to be a decimal point on this one. 30. So 2 times 64 is going to equal 128. And at this point, we actually don't even need to do any more of the problem. We don't need to do any more math because there's only one answer choice that starts with the number 2, the one that's 20%, answer choice C. So that's doing the math does not necessarily mean you're going to be going any longer than if you do an estimation method. So anyway, obviously I've just given it away. The choice C is the answer. The other way you can look at it is that 13/64 is pretty close to 13/65. 64ths versus 65ths, pretty small difference. Unless we're talking about, 1/64 of $1 million billion versus 1/65th, I guess I would be willing to take the smaller fraction in that case. It would still be a lot of money. So anyway, 13/65 is basically the same thing as 1/5, which is then 20%. So even though 13/64 is slightly larger than 20%, it's only slightly. So estimating gets us the right answer, as does your friend and mine long division. I'm being sarcastic. I actually really don't like doing long division, but you totally need to be able to do it on the GMAT at will whenever you need to. So answer choice C, whichever method you get to the correct answer, it's still the same correct answer. Choice C. On to number 93. Okay, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Oh yeah, lists. So if the median of the numbers in list 1 above is equal to the median of the numbers in list 2 above, what is the value of x? So list number 1 has the numbers 3, 6, 8, and 19. List 2 has 3, 6, 8, 19, and then x. It had x first, but we don't actually know the value of x, so it could be anywhere in there. So if the median in the list of the numbers in list 1 is equal to the median of the list 2, what's the value of x? So first off, of course, we should figure out the median of list number 1. It has only numbers in it, no variables, so we can figure that out. So remember, the median, when you have a list of numbers, the median is either just the middle number on the list. So in all cases, we're assuming here that you've listed the numbers in increasing order. So we have 3 at the one end and 19 at the other. The middle number is the median when you have an odd number of numbers. When you have an even number of numbers, there is no middle number, so you have to compute the median as the average of the middle two numbers. In this case, the average of 6 and 8. They made it a little bit easier for us. You don't actually have to use the average formula because there's only one number between 6 and 8, and that's 7. So the median of set 1 there equals 7. And so the median of set 2 also has to equal 7. So we have the numbers, and they're exactly the same numbers that we had in set 1. The 3, 6, 8, and 19. So the only way that the middle number of set 2 can be the same is if x is the middle number, right there. And the only way it can be the middle number and have the same median is if x itself is 7. If you put x anywhere else, it will change which number is the middle number. So if you have x between 3 and 6, the middle number ends up being 8. Or sorry, it ends up being 6. If you put the x where I first listed it, if you put it after 19, then 8 is the median number because it's the middle one. It's always just the middle one without any calculation. The only time you have to calculate is when there's an even number of numbers in the list. So 7 must be the median, and x must be that middle number. So that leaves us with answer choice B, 7. $94 on page 165. So our answer choices are 50%, 53%, 54%, 55%, and 57%. So when the numbers are closer together, they're expecting a computational error rather than a conceptual error. It's possible that you could have a question where the one leads to the other, but the closer the numbers are, the more they're figuring you're going to do the math wrong. So in a certain city, 60% of the registered voters are Democrats and the rest are Republicans. In a mayoral race, if 75% of the registered voters who are Democrats and 20% of the registered voters who are Republicans are expected to vote for candidate A, what percent of the registered voters are expected to vote for candidate A? So we can just do a little chart. We'll use D for Democrat and R for Republican. So we know that 60% of the registered voters are Democrats, and all the rest are Republicans, so it must be 40% who are Republicans. And let's just pretend there are exactly 100 people in this city. It stretches the definition of city, but it makes the math a lot easier. So let's pretend there are actually just 60 Democrats and 40 Republicans. You could pick a different number if you want, but when you're dealing with percents, starting off with 100 is, well, it's not always going to be right, but it's very, very, very likely to make your life a lot easier. Okay, so we know that 75% of the Democrats are going to vote for candidate A. So that's 3/4 of 60. So 60 divided by 4 is 15. 3 times 15 is 45. So 3/4 of 60. So 75% of those guys, that's 45 in this column, voting for candidate A. Then we also find out that 20% of the registered voters who are Republicans are also going to vote for candidate A. So 20% of 40. You could do the math, or you could say that 10% of 40, remember, just when you have to figure out 10%, you can just move the decimal point over 1. So 10% of 40 is 4. We need to know what 20% is, so that would just be twice that. So 20% of those guys is 8. And we need to know what percent of the registered voters are expected to vote for candidate A, we would add the 2 percents together. 45 plus 8 equals 53. And since we had exactly 100 people in a certain city, 53 voters equals 53% of the voting population. Choice B is our correct answer. Okay. Page 165, winding down page 165, we're in the second column now, question number 95. So, some interesting looking fractions in the answers. 29 sixteenths, 19 sixteenths, 15 sixteenths, 9 thirteenths, and big 0 for choice E. Oh my goodness, it's almost not worth reading this one out loud. So I'll just write it out. So it's 1/2 plus the larger quantity of the lesser quantity of 2/3 times 3/8. That quantity divided by 4. So 1/2 plus that minus 9 sixteenths. So you may remember your order of operations. PEMDAS, PEMDAS, however you want to say that, but it stands for parentheses, exponents, multiplication, division, addition, subtraction. Do those things in that order. The important thing here is the first letter P. So we need to do the parentheses first. However, multiplication and division they're very similar sorts of operations in that you can do them in any sort of order, and you still get the same answer. So we can, and the other thing to remember here is that when we're dividing by 4, when you're dividing by numbers, you can just turn it into a multiplication problem by multiplying by the inverse. So dividing by 4 is the same thing as multiplying times 1/4. Let's rewrite it that way. So 1/2 plus 2/3 times 3/8 times 1/4 minus 9 sixteenths equals our mystery number. And so whenever possible, you want to do some canceling out of fractions and stuff, so we can cancel out the 3 in the numerator and the 3 in the denominator. We can also do a little canceling here. A 2 in this numerator, we can then divide this guy by 2 also, so we're left with a 4. So we're left with 1/2 plus, all that's left in our big bracket here is 1/16 because we're left with just 1 in the numerator and then 4 times 4 in the denominator. So 1/2 plus 1/16 minus 9 sixteenths equals something that we haven't solved yet. Obviously, maybe it's not obvious, but by the time you are done studying for the GMAT, it will be obvious. When you have fractions with multiple different denominators, you need to have all of them with the same denominator before you can do the addition and subtraction. And it looks like sixteenths are going to be the winner on this one because we have 1/16 and 9 sixteenths, and then 1/2 sitting out there by itself, looking like it came dressed wrong to a party or something. So let's convert 1/2 to sixteenths. 1/2 in sixteenths is the same thing as 8 sixteenths. So 8 sixteenths plus 1/16 minus 9 sixteenths. If you're following along, 8 plus 1 is 9, so this ends up being 9 sixteenths minus 9 sixteenths. And that equals 0, choice E. Interestingly, or somewhat interestingly, of course, E is the only one that's not expressed as a fraction in the answer choices. And very often, the one answer that is expressed in different terms is there to attract guessers. Someone saying, oh, that answer stands out, I'll just pick that one. Maybe that's the trick. In this particular case, so it's not that that one is always wrong by any means, and in this case, clearly it's the correct answer. Choosing answers just based on gut feelings generally isn't an optimal strategy anyway. So whenever possible, do it using the actual math or an educated guess. In terms of educated guesses on this one, it would have made the most sense to choose A, B, or C because we had sixteenths in the answer choices, or in the actual problem. We had 9/16 in there, so it was probably going to have to be 16ths no matter what. Anyway, it wasn't any of those. This time it was choice E. Page 165, number 96. 16, 72, 112, 128, and 142. So water consists of hydrogen and oxygen, and the approximate ratio by mass of hydrogen to oxygen is 2 to 16. Approximately how many grams of oxygen are there in 144 grams of water? So whenever you're given ratios, one of the things that should be, so we have this ratio of 2 to 16. One of the things you should be asking yourself or telling yourself whenever you get a ratio like this is, what is the whole then? So if for every 2 bits of hydrogen we have 16 bits of oxygen, I mean this is the ratio by weight, but let's just pretend it's bits for a second. If the ratio is 2 to 16, then the total is going to be out of 18, because 16 plus 2 is 18. So the ratio of hydrogen to total water, we'll use H because that's the symbol for it anyway. The ratio of hydrogen to water is 2 to 18. The ratio of oxygen, we'll use O, is 16. That's a 6. 16 to 18. Okay, so the question is, so then the ratio, the question is asking us about grams of oxygen to grams of water. So it's this ratio that we're going to be using. How much of the mass of oxygen relative to water, how much is in 144 grams of water. So if the ratio is 16 to 18, for every 18 grams of water, there are 16 grams of oxygen. We just set it up as a proportion. We don't know how many grams of oxygen are in 144. We can do a little bit of simplification. We could say that 16/18 is the same as 8/9, just to keep the math a little bit more tolerable. And in this case, we just need to solve for x, right? So we need to multiply both sides times 144. 8/9 times 144 over 1 equals x. So in this particular case, we can divide the 144 by 9. So I'll do that over here. You could multiply it first and then divide by 9, but since it is going to turn out to be divisible by 9, it makes our life easier. So 9 doesn't go into 14 at all. Or no, it goes into 14 once. So 9 goes into 144 16 times. So this is the same thing as putting a 1 there and a 16 there. So 8 times 16 then equals 8 times 16. And these were both over 1, so we can write it or not as we see fit. Equals x. 8 times 16 is 128. And the final answer, what this is answering then is, out of 144 grams of water, 128 grams of that are oxygen. Answer choice D. Okay, last one on page 165, number 97. We have -3, -1/2, 0, 1/2, and 3/2. So if x times the quantity 2x plus 1 equals 0, and the quantity x plus 1/2 times the quantity 2x minus 3 equals 0, then x equals some sort of something something, namely some sort of one of these answer choices. So we have x times 2x plus 1 quantity, and we have x plus 1/2 times 2x plus 3. They both equal 0, so these two equations are equal to each other, but there's really not going to be an easy way for us to eliminate parts of this and solve for x without actually multiplying it out. We can see in both cases just by kind of looking at it that x times 2x is going to give us a 2x squared, and by using FOIL, remember your buddy FOIL, first, inner, outer, last, when you're multiplying binomial expressions, that's also going to give us a 2x squared here. So there is hope that if we multiply each of these out, we will be able to just eliminate the 2x squared from both sides. So that's totally what we're going to do. And again, since each of these equations equals 0, the equations also equal each other. So this guy over here, I'm going to make more room for it. So this ends up being 2x squared plus x. And this guy ends up equaling, we do the first terms, 2x squared. The outer terms this is actually, I did plus 3 there, but it should be minus 3. This is a minus. So 2x squared minus 3x for the outer terms. The inner terms, 1/2 times 2x is just the same thing as regular old x. And then the last terms, negative 3/2. So as originally promised, we're going to ditch these 2x squareds first, just subtract them right away. We're left with x equals minus 2x, because minus 3x plus 1x is minus 2x, minus 3/2. And let's just add 2x to both sides. Then we end up with 3x on the left-hand side. 3x equals negative 3/2. So, we divide negative 3/2 by 3. It's the same thing as multiplying times 1/3. So negative 3/2 divided by 3 is equal to negative 3/2 times 1/3. 1/3, not 1/2. These two 3's cancel each other out. X equals negative 1/2. Choice B. On to the next page. Turning the page over. Page 166, number 98. So we have 5, 50, 10 to the 5th, 5 to the 10th, and 8 to the 10th minus 3 to the 10th. Clearly, somebody's going to be testing our exponents here. Okay, so on a scale that measures the intensity of a certain phenomenon, a reading of n plus 1 corresponds to an intensity that is 10 times the intensity corresponding to a reading of n. On that scale, the intensity corresponding to a reading of 8 is how many times as great as the intensity corresponding to a reading of 3? Okay, so what this is saying is that, every unit on this scale, on this scale, every time you go up 1, it is 10. That number is 10 times bigger than the number before. So every increment of n is a power of 10 higher. So and so basically 8 is the the one increment, or the one measure that we're looking at. 3 is the other. How much greater is 8 than 3? So the difference between 8 and 3 is 5. So there are 5 powers of 10 difference between 8 and 3. So let's just do it another way. If we had 3 here and 8 here, 3, 4, 5, 6, 7, 8. You wouldn't have to write it out this way on the real GMAT, but just to demonstrate, going from 3 to 4 is times 10, 4 to 5 is times another 10, 5 to 6. Every time we go up 1, it's times 10. So going up from 3 to 8 5 times, we have gone to 5 powers of 10. 1, 2, 3, 4, 5. And since it's powers of 10, that's 10 to the 5th. Answer choice C. Ta-da! And again, if ever you're unsure, with small enough exponents, you can actually kind of write things out like this on multiple types of GMAT problems. It takes longer, but if it takes you an extra 30 seconds and you can get the question right, that's well worth your time, because questions right on the test, really that's all that matters, right? So, okay, on to the next one, number 99. Page 166. So we have 0, 1, n plus 1, n plus 2, and n plus 3. So for the positive numbers n plus 1, n plus 2, n plus 4, and n plus 8, the mean is how much greater than the median. Okay, so remember when you're writing numbers out, so it says they're positive numbers, so which means if we're adding numbers to n, the numbers are getting bigger. So we have n plus 1, n plus 2, n plus 4, and n plus 8. Those are our numbers on the list. And we're trying to determine the mean and the median. So remember, the median is just the middle number when you have an odd number of numbers. And in this particular case, we do have an odd number of numbers. 1, 2, 3, 4, 5 numbers. So n plus 2 is the median. That's the middle one. Median equals n plus 2. And so the question is, how much bigger is the mean than that? The mean is the average, where you add up all the numbers in the set and then divide by that number of numbers. So if we wanted to figure out the mean of the set, that's n plus 1 plus n plus 2 plus n plus 4 plus n plus 8. That's a lot of n's. All divided by 5, because we have 5 numbers in the set. So 1, 2, 3, 4, 5, that's 5 n's. And 8, 9, 10, 11, 12, 13, 14, 15. It ends up being 5n plus 15 divided by 5. Divide the numerator and the denominator by 5. We end up with n plus 3. So this is the mean, or average, equals n plus 3. And of course, there's a trap answer right there, or two trap answers. Choice D is just the median, which we figured out. Choice E is the mean, which we just figured out. But the question is actually asking how much greater is the mean than the median. N plus 3 is 1 more than n plus 2. So answer choice B is our buddy. It's the correct answer. Gets a smiley face. Okay, moving on. When you're given average problems like this, you can also do a little bit of figuring, and you can say, well, this guy is 1 less than the median, and you can say this guy is 2 less, and then this one is 2 more, and this one is 6 more, and so this one's 8 more, and this one's minus 3, and so it's a difference of 5, and you have to divide that over 5 different numbers, and so you would still end up with 1 as the average being 1 higher. Probably just easier to stick with the formulas on this one. Anyway, moving on. Number 100. We hit the century mark in the problem solving section. So, yikes. Choice A, 1,738 divided by 9. Choice B is 322. C is 490. D is 554. And E is 2,898 divided by 5. Okay then. So if t equals 5/9 of the quantity k minus 32, and if t equals 290, then k equals what? Okay. So 2 formulas, 2 variables, and we're able to substitute one. T equals 5/9 of k minus 32. And we also have a second equation, t equals 290. So we can substitute this value of t in to our previous thing here. So 290 equals 5/9 of that quantity, k minus 32. We can probably save ourselves a little bit of work here by saying, and so we're going to multiply both sides times 9/5 to get rid of the fraction here, get rid of the coefficient there on our quantity in parentheses. So 290 over 1 times 9/5 equals k minus 32. And again, whenever possible, rather than multiplying by 9 and then dividing by 5, it'll probably be easier to divide 290 by 5 right away. So 290 divided by 5, 5 goes into 29 5 times, leaving a remainder of 40. So this ends up being 58. It's an 8. We can cancel this out to a 1. So now we're only left with 58 times 9 over 1 equals k minus 32. So we multiply it out. 58 times 9 equals 522 equals k minus 32. And at this point, we actually don't even have to do any more math. There's only one number that starts with a 500 in the answer choices. That's answer choice D. But just to be thorough, 522 plus 32 equals 554 equals k. I mean, again, that saved, 7 seconds of time. But if you're able to recognize that type of thing quickly, 7 seconds multiplied over maybe 10 questions where you can do it, that's, almost enough time to answer a question quickly. So it's worth it to just double check as you're doing your problems to see if you are getting an answer that is realistic for the answer choices. Yeah, because it's a good way of checking to make sure that you haven't gone too far astray. Anyway, on to the next one. Still page 166, number 101. So we have 0.22, 0.31, 2.5, 2.50 I guess, 3.21, and 4.56. So the water from one outlet flowing at a constant rate can fill a swimming pool in 9 hours. The water from a second outlet flowing at a constant rate can fill the same pool in 5 hours. If both outlets are used at the same time, approximately what is the number of hours required to fill the pool? It's an interesting question. This type of question actually used to be much more common on the GMAT. This is what's called the work formula. It's okay. Formula. Tablet doesn't like me today. So the work formula, when you have multiple machines working at a constant rate in conjunction, you need to know what the how long each machine can complete the job individually. So, A is one machine and B is one machine, and you can have any number of machines in this work formula. In this particular case, we have 2. So the work formula then is derived from 1 over A plus 1 over B, which is what they give you in the explanation in the official guide. 1 over A plus 1 over B equals 1 over T, and then you solve from there. So the work formula is then A over AB, or sorry, A plus B over A times B, if you have 2 machines. Which is really just saying we did A plus B and we figured out the common denominator of 1 over A plus 1 over B has the common denominator of AB in the fraction. If you had 3 machines, you would actually have to derive it from 1 over A plus 1 over B plus 1 over C equals 1 over the total. And then when you're done, when you multiply this whole thing out, you flip it over, and then that's the total time of the however many machines working together. The common denominator of A plus B, of 1 over A plus 1 over B and 1 over C, the common denominator has to be A times B times C. So then we would have BC over, sorry, A plus B plus C. No. I'm getting it confused, sorry. And maybe this is extra information. It would be BC over ABC plus AC over ABC plus AB over ABC. So BC plus AC plus AB all over ABC. It would be the three machine thing. Anyway, these work problems are not common enough on the GMAT that you should prioritize memorizing the work formula or how to derive it over most other things like using exponents or radical signs or how to do triangles. However, if you've got spare brain space and or just like knowing formulas for things, if that's easier for you to remember than re-figuring out a problem like this every time, just memorize the work formula. So we just plug in the two numbers. A plus B, one machine works at 5, the other one works at 9, over A times B, 5 times 9. That ends up equaling 14 over 45, and that's 1 over t. So then we need to invert that to figure out what t actually equals. So t equals 45/14. Of course, we're not given it in fractional form, so we would actually want to do the division. But you can just kind of look at this and say, 14 goes into 45 more than twice and fewer than 4 times, because 4 times 14 is 56. So we know that it's going to be 3 point something, who knows what. There's only one answer choice that has 3.21. And if you did the math, it still comes out to be that. So you could also say 45/14 is really close to 45/15, which is of course a straight 3 over 1. Again, putting you in the vicinity of answer choice D. What's this next one look like? I think we have time to do one last one before we finish up. Page 166, number 102. So we have as our answer choices 40, 60, 80, 100, and 120. So if a square mirror has a 20-inch diagonal, what is the approximate perimeter of the mirror in inches? So square mirror, pretend that's square. That's pretty close. It has a diagonal of 20 inches. So, and we need to find the perimeter. So the perimeter of a square is, so if one side is x, perimeter is all 4 sides together. Perimeter is going to equal 4x. But first we have to figure out what one of those sides equals. And we have a couple different ways we could do it. We could use the Pythagorean theorem. This is a right triangle because we're dealing with squares. So a squared plus b squared equals c squared. The squares of the sides added together equal the square of the hypotenuse. So x squared plus x squared is going to equal 20 squared. 2x squared equals 400. So x squared equals 200. So then you're left with x equals the square root of 200. And in terms of estimating square roots, you do need to be able to look at these guys and say, well, okay, there is a perfect square in there. X equals, it's the square root of 2 times 100, which is then x equals the square root of 2 times the square root of 100. So x equals 10 times the square root of 2. You don't need to know the value of the square root of 2 in your head, but from here actually you can just figure out the answer choices because, so it's going to be 10 times something, okay? This is the same, so 10 times the square root of 2 is not going to be 4, right? The square of 2 is 4, so the square root of 2 is definitely not going to be 4. And the square root of 2, basically, you can also kind of think to yourself that the square root of 2, whatever it is going to be between 1 and 2. 1, 2, somewhere in the middle here is the square root of 2. Because 2 here is the square root of 4, right? So the square root of 2 has to be less than 2 and more than 1. So, and the perimeter is actually 4x. So if x is 10 times the square root of 2, the perimeter equals 4 times that, 40 times the square root of 2. Choice A is just 40 times 1. Choice B is 40 times 2. And we already established that the square root of 2 is between 1 and 2. Therefore, choice B must be the correct answer because it's bigger than A and smaller than C. Choice D and E are way out. So that's going to be a good place to stop. When we pick up next time, we'll start off with question number 103 on page 166. If you're watching this live, we are taking a break for the Thanksgiving holiday, and we will return on Monday. If you're watching this in a pre-recorded version, you can just imagine that this took place back at Thanksgiving, and you'll be able to watch the next video right away because that's how the miracle of the internet works. So my name is Jim Jacobson. You've been watching Grockit's OGTV, GMAT edition, 12th edition of the guide, and we'll see you next time.